The glycogen stored in our liver, okay, glycogen that's present in the liver can give us 1 day's requirement of glucose. Meaning, if you had to synthesize glucose from the glycogen present in the liver, you can do that with the liver glucose, and it will supply you with a glucose supply for 1 day. But for more than 1 day, if a person is doing a heavy exercise or if they are fasting, then there will not be enough glycogen to make glucose. Then what happens is that glucose will be synthesized from carbon atoms, okay, carbon atoms that are found in non-carbohydrate molecules like food sources like amino acids and glycerol and fat, right? So glucose synthesized from carbon atoms obtained from non-carbohydrate compounds, that is known as gluconeogenesis. Okay? Now, from the carbon atoms, these carbon atoms could be from amino acids or glycerol from fats, right? These carbon atoms are converted to pyruvate mostly, right? And then from pyruvate, it goes in the reverse direction of glycolysis. What is glycolysis? Glycolysis is glucose to pyruvate, 10 reactions, right? Gluconeogenesis is pyruvate to glucose in the same order of 10 reactions. However, 3 of those reactions are not reversible. So if all of the reactions 1 through 10, if all were reversible, we could have just gone back this way, reversible. Some of them are not reversible. Which are the reactions that are not reversible? 1, 3 and 10 are not reversible. So basically what happens here is that from 2 pyruvate molecules, okay, so from amino acids you get pyruvates, okay. From the 2 pyruvate molecules you get 2 oxaloacetate molecules. 2 oxaloacetate molecules, and this is not a reversible reaction of glycogenesis, okay, glycolysis. So from 2 pyruvate molecules you get 2 oxaloacetate, and the enzyme here is pyruvate carboxylase, right? And from there you get 2 phosphoenol pyruvate, and the enzyme here is phosphoenol pyruvate carboxykinase. Okay? And if you recognize this molecule, this is the result of step 9 in our glycolysis. So from step 9, all the reactions will go in reversible order all the way up to fructose 1,6 biphosphate. Okay, now what you have to remember is that this is the end result of step 3. Okay, this is the end result of step 3 in glycolysis. So from fructose 1,6 biphosphate, from Fructose 1,6, actually bisphosphate, not biphosphate, bisphosphate. Using two of these molecules, fructose 1,6 bisphosphatase enzyme will give rise to fructose 6 phosphate. Fructose 6 phosphate. From there, in the reversible reaction, glucose 6 phosphate. Now the last step, which is the first step of glycolysis, this is not reversible. You get glucose with glucose 6 phosphatase as the enzyme, and then this glucose moves into the bloodstream. This moves into the bloodstream. So the synthesis of glucose from carbon atoms obtained from non-carbohydrate molecules is gluconeogenesis. Gluconeogenesis is essentially, for the most part, reverse of glycolysis, and the steps that are not as same as glycolysis are step number 1, 3 and 10.